I might have just marked myself. Okay, hello, welcome to day 1 of AP Chem review. Yay! Oh my god, I marked the wall. Okay, so 4 questions a day, progressing through the units. Well, 4 correctly answered questions a day. We got it. Am I at all qualified to teach? No, but we're all qualified to learn together. Okay, so let's just get started. Okay, so I'll put the question right here, so you can pause your screen if you want, but I'm just gonna work through it, so woo. And then you may want to have your periodic table on hand. First off, we see our molar mass is in grams per mole, and just so that we don't make a mistake, 1,000 grams is equal to 1 kilogram, right? So we know that, and then so we can make that conversion already. So we have 7.89. I can write a little bigger. 7.89 kilograms equals, move the decimal 3 places, 7,890 grams. So we can't forget that step. And then we can find the formula weight of aspirin, which they tell us is C9H8O4, right? And then you can use the periodic table that they give you on the exam, right? So the molar mass of carbon is, so we do 9, right? 9 times, because there's 9 carbon molecules, so 9 times 12.01, it's in grams per mole, plus 8 times 1.008 grams per mole, plus 4 times 16.00 grams per mole. Oxygen is always easy to remember because it's 00. Right. That looks correct enough. I don't know if I'll have access to a calculator on the exam, but for now I've been using one. So 108.09 plus 8 times. You could probably do it all in the calculator too, but I'm just gonna write out everything. 0.64 plus 4 times 1.664, right? And then you add all those up, plus 8.064 plus 108.09, enter, so 180.154 grams per mole. So that is our formula weight for aspirin, right? And then we're trying to determine the moles in this much aspirin, right? So we can multiply these two, because this is just 180.154 grams per mole, so that's per 1 mole. So we can cancel out the grams. So 7,890 grams times, so 1 mole, right, per 180.154 grams. So this is like the conversion factor, so that we can just cancel out the grams, right? So then basically you're just doing 7,890 divided by was I doing? 180.154. And then the answer are 43.7958, whatever, but it says 3 significant figures, so you just stop at 43.8. Oh, I'll write the unit, moles. Right? Okay, hopefully that's correct. First problem of the day, or not the day, the video. And that is correct. Yay! Celebrate the small wins. I haven't forgotten. Molar mass. Yay! Okay, next one. I'll put the question just right here while I erase the board. So you can pause and check that, or try that if you want. Okay, well, we'll write down what we know, right? So we have that many grams per mole. And so if we find moles, we have to use Avogadro's number. Okay. I think they give that to us on the formula sheet. Please give that to us, otherwise I'm not ready. This is why we're starting early, you know? Okay, they give us Avogadro's number. Okay, cool. Do I remember how to use it? No. Okay, I'm gonna call for backup. No one said we couldn't use notes. Got it, okay. So pretty much we just find the moles and then we multiply that by Avogadro's number. So I'm just gonna write out Avogadro's number real quick. Oh, okay. So I'm just gonna say, to my understanding, spelling his name right, equals, okay, so 6.022 times 10 to the 23rd. Thank God they give us that. Molecules per mole. Okay, well, molecules is like a general term, right? Okay. Yeah, okay, cool. And then the question of the hour is, how many milligrams are in a gram? I want to say 1,000, right? That sounds right. Would it be wrong? Yes, okay. Okay, and then there are 1,000 milligrams in a gram, right? So I'm gonna write down 1,000 milligrams. I really didn't have to write that out. In 1 gram, right? Okay, so then we can find the moles in our silicon, in that amount of silicon, right? How many grams of silicon are we given? Oh, it tells us. Okay, cool. So if we have 98.8 milligrams of silicon, then that means, equals 0.0988 grams, right? Okay, that looks correct. Okay, and then we can just go ahead and multiply that by the molar mass in order to cancel out the grams, right? Did I use a completely different number? Oh, I did. This is 92.8. Oh, LOL. Oops. Okay, well. Okay. I made a mistake there. Okay, so that one is 1.99 times 10 to the 21st. Okay, that makes sense. Cool. Okay, I got some water. Now, 2 more questions. Yay! Making a lot of stupid errors. That's okay though. But good on this one. I want to do that again. Okay. I'll put the next question right here. There it is. Okay, so formula unit. Haven't seen that one in a while. Formula unit, fundamental unit of an ionic compound. So I assume we use Avogadro's number again to get the amount of molecules. Okay, so I think in this case, because it's CaCl2, which is made up of several atoms, and we're not calculating atoms, we're calculating, in this case, the molecules. Specifically, this molecule, CaCl2. Okay, cool. Right? Easy peasy. Lemon squeezy. I'm gonna make another stupid error. That's okay though. So we do the same thing, right? We find the molar mass of CaCl2, right? Oh, our sample is given in grams already. We don't have to do any conversion. This could not be better. Okay, so we take out our trusty periodic table and use the molar mass. Okay, so Ca, so calcium is, I don't know that one by, probably should, but 40.08. Okay, so I'm just gonna call it MM. Okay, 40.08 grams per mole plus 2 times chloride, which is 35.45 grams per mole, right? So then our total is 2 times 35.45, enter, plus 40.8, because there's only, or 40.08, excuse me, there's only one of that atom, the calcium atom in that molecule, so multiply by 1, which is just itself, so in total that's 110.98 grams per mole. Okay, cool, great. So then we have that, and then we have our sample. Our sample consists of 27, I'm gonna make sure not to copy this down wrong, 0.4 grams, So we multiply that by the molar mass. So we put moles on top to cancel out grams. 110.98 grams, cancel. So 27.4 divided by 0.98, right? And make sure I'm not making any errors. Cool, that looks great. Okay, so we have the amount of moles. This very small amount of moles, okay. In comparison to the others. Okay, so we have about that many moles, right? I'm gonna do it in the calculator though, so it's gonna be more exact. And then we multiply that by Avogadro's number, right? Which they give us on the formula sheet that we're given. Pull that thing out. But so 0.2469 times, I bet I can remember it. What was it? It was like 6.22 times 10 to the 23rd molecules per mole. Oh, this is in mole. Oh, 6.022. That was close. Times 10 to the 23rd, cool. Okay, so molecules cancel out, moles cancel out. And then we are left with that number times Avogadro's number, which is 6.022 times 10 to the 23rd equals 1.48. 3 significant figures, I assume? Yep, 1.49. Times 10 to the 23rd, yeah, molecules. Cool. So 1.49 times 10 to the 23rd. Did we do everything right? Hopefully. Yes! We got one! Yay! One more to go. Okay. I will put this one right here. So you can start on that if you want. If not, okay. So we have our starting number, 2.01 times 10 to the 24th atoms. So that's the same as molecules because it's just sulfur. It's the same thing. So molecules, right? And then we divide that by Avogadro's number. So, divided by, and the Avogadro's number, we know this now, 6.022 times 10 to the 23rd molecules per mole. Yes, that is correct. Okay, so then molecules is going to cancel out, and then we're left with, so then we're left with the unit moles, right? So we take the 2.01 times 10 to the power of 24, right? All right, I'm gonna make sure my Avogadro's number is correct. Yes, it is, okay. To the power of 24, and then we divide that by Avogadro's number, which is that 6.022 times 10 to the 23rd, and then, sorry, my calculator is always in the way. Ugh. Okay, everything's looking pretty. Okay, so we're giving that much, and that number is in moles because if you just think about it, your thing is going to be that, but it's just the reciprocal, so it's moles over that number, so it's just going to be moles. So it's going to be 3.33, call it 8. It doesn't matter, I'm going to keep it in my calculator. Moles, right? And what are they asking for? They're asking for the grams. Okay? And then you just take that number and multiply it by the molar mass of sulfur, which is 32.06 grams per mole, right? Sorry, blocking the way. Moles cancel out, and then you multiply that. I just do that in the calculator so everything's clean. 32.06. And final answer 107.3 significant figures. So you just end there. Wait, yeah. 107 grams. It looks like this is the last one, so I gotta kind of make sure that it's perfect. Was there anything that could have gone wrong? Yes. That looks correct enough. Okay, cool. I'm gonna try to put that in. I'm glad I don't have to type in scientific notation. 107, check. Yes, done. Ooh. Good job. Well, that was day 1 of AP Chem review. Moles and molar mass. I gotta go find the cap to this. I don't know if that was helpful at all, but it was helpful to me, and at the very least entertaining, because I made so many errors in the beginning. But thank you for coming, and I will see you tomorrow.